Good morning, all of you. The last class we discussed about the non-repeated linear factor and repeated linear factor on irreducible quadratic factors problems, how to resolving into a partial fractions. We discussed the last class. There we know that how to resolve into a partial fraction whenever given the non-repeated and repeated and also irreducible quadratic factors. And also we learn about the different type of fraction, proper fraction and improper fractions. Okay, so many topics are covered and how to solve the different types of problem we'll learn about them. Today's class we discuss the partial fraction type 3. That means what? The last method. The last method means it is repeated irreducible quadratic factors. Okay, here we discuss about the problems irreducible quadratic factors whenever repeated. Okay, now we see the objectives. On completion of this period, you would be able to resolve the given rational fraction into partial fractions when the denominator has repeated irreducible quadratic factors. Okay, you see here what? Repeated irreducible quadratic factor. Whenever the repeated irreducible quadratic factors are there, then how to write in partial fraction format we have to see in this class. Okay, here the problems on type 4. That means what? The method number 4. We see the problem, the number 1 question. Resolve x divided by x minus 1 into x square plus 1 whole square into partial fractions. Okay, you observe here in this problem x divided by x minus 1 x square plus 1 whole square. In the numerator degree is 1, the denominator degree is what? 5 is there. So that when we see the numerator and denominator degrees, this is a proper fraction. We know that the proper fraction is possible to write resolving into a partial fractions. Okay, here we have a non-repeated linear factor and one repeated irreducible quadratic factor in the denominator. You observe here x minus 1 is non-repeated linear factor, x square plus 1 is actually the irreducible quadratic factor, but here repeated. How many times repeated? 2 times is there. So that x square plus 1 whole square is possible. So that this is called what? Repeated irreducible quadratic factor. Let x divided by x minus 1 into x square plus 1 whole square. Okay, that is equal. X minus 1 is one linear factor, then how to write? A by x minus 1 plus, okay, here the repeated linear factor is completed. Now we see the quadratic factor, but here the quadratic factor is repeated here. So that bx plus c divided by x square plus 1 plus dx plus e divided by x square plus 1 whole square. Okay, how to write in partial fraction here? Repeated factor is, non-repeated factor, linear factor is a by x minus 1. Repeated irreducible quadratic factor is bx plus c divided by x square plus 1 plus dx plus e divided by x square plus 1. Now we have to find out here a value and b value and also c value and d value and e value. Okay, now we have to choose. This is equation number 1. Next step, x is equal. Now we can do the LCM procedure. Then after cancel the remaining denominator part. Okay, and after completing the simplification, we get a into x square plus 1 whole square plus bx plus c into x minus 1 into x square plus 1 plus dx plus e into x minus 1. Here x is equal, now we have to take the coefficient outside, a plus b into x to the power of 4 plus minus b plus c into x cube plus 2a plus b minus c plus d into x square, and also the remaining plus minus b plus c minus d plus e into x plus a minus c minus e. Sorry. Okay. After simplification, now we have to choosing the substitution method. Put x is equal to 1. We get 4a is equal to 1, that is a is equal to 1 by 4. Now put x equal to 1 in the equation. Whenever the x is possibility there, we have to substitute 1. We get a is equal to 1 by 4. Comparing coefficient of x to the power of 4. Here comparing the coefficient of x power 4, we get a plus b equal to 0, that is b equal to minus a. We know that already a is equal to what? 1 by 4. So that in the place of a minus 1 by 4, we get. Comparing the coefficient of x cube, we get minus b plus c is equal to 0, that is c is equal to b. We know that what is the b value? Minus 1 by 4, the same minus 1 by 4. Now comparing the coefficient of x square. Comparing coefficient of x square, we get 2a plus b minus c plus d equal to 0. That is d is equal to minus 2a is equal to what? What is the a value? Already 1 by 4. Then simplify, we get a d is equal to minus 1 by 2. Now the last one, comparing the constant term. Now here comparing the constant term, we get a minus c minus e equal to 0. That is e is equal to a minus c equal to 1 by 4 plus 1 by 4. We get 1 by 2. A is equal 1 by 4 and b is equal minus 1 by 4 and c is equal minus 1 by 4 and d is equal minus 1 by 2, e is equal 1 by 2. These 5 values we have to substitute in the place of equation number 1 whenever the a value is what? 1 by 4. That is substituting the a, b, c, d, e in 1, we get x divided by x minus 1 into x square plus 1 whole square is equal 1 by 4 into x minus 1. Here the a value is what? 1 by 4. So that in the place of a we substitute 1 by 4. This is only the linear factor. The remaining bx plus c. What is the b value? Minus 1 by 4. C value is what? Minus 1 by 4. So that we write bx plus c, 1 by 4 take the common and we get x plus 1 by 4 into x square plus 1, and also the e value also minus 1 by 4 and we get minus 1 by 2 and 1 by 2 is there. So that 1 by 2 take common, we get x minus 1 divided by x square plus 1. Okay, you see here and repeated irreducible quadratic factor. First we see the denominator part. Okay, here the repeated irreducible means we have to write in the format bx plus c by x square plus 1 and also write dx plus e by x square plus 1 whole square. Here x minus 1 is non-repeated linear factor. Whenever the linear factor is there, we write a by x minus 1, that's enough. Here when we compare the denominator part, one linear factor, one repeated irreducible quadratic factor is there. Whenever the repeated irreducible quadratic factor is there, then write a by x minus 1 and bx plus c by x square plus 1 and dx plus e by x square plus 1 whole square. Here we have to compare, we have to do the LCM procedure, the same and comparing the coefficients. Now find the a value and b value and c value and d value and e value. Okay, whenever get these 5 values, we have to substitute in the equation number 1. Okay, now the second question we observe, resolve x square plus x plus 1 divided by x square plus 1 whole square to partial fraction. Okay, you observe in the denominator part and numerator part, confirm this is a proper fraction. Whenever the proper fraction is confirmed, it is possible to write the partial fractions. Let x square plus x plus 1 divided by x square plus 1 whole square is equal. Here x square plus 1 whole square, repeated quadratic factor, repeated irreducible quadratic factor. So that repeated 2 times is there. Then how to write in partial fraction format? Ax plus b divided by x square plus 1 plus cx plus d divided by x square plus 1 whole square. Here printing mistake is there. Cx plus d is exactly right. Here the next step, we can do the LCM procedure the same way. The denominator values will be cancelled. Then after simplification, we get x square x cube plus x plus 1 is equal ax plus b into x square plus 1 plus cx plus d. Now we have to choose, this is equation number 2. Equating the, now here what is the suitable method? We have to observe substitution method or comparing the coefficients. Equating the coefficients of x cube, x square, x and constant and both sides of the 2 respectively, we get 1 is equal to a. We have to choose, this is equation number 3. Here the comparing the coefficient of x cube coefficient is what? 1 is there. So that in the left side is 1, the right side is a. The same way comparing the coefficient of x square. In the left side is not available the x square, so that we have to take 0. In the right side is b is there. Now we have to choose, this is equation number 4. Now comparing the coefficient of x terms. In the left side part is 1 is there, in the right side part is a plus c is there. We have to choose, this is equation number 5. Now the comparing the constant term, in the left side is 1 is there, in the right side is b plus d. We have to choose, this is equation number 6. From 5 and 6, from 5 and 6 we have to subtract them. C equal, from 5 c is equal 1 minus 1 equal to 0 and 6 d is equal 1 minus 0 equal to 1. Substituting, a is equal to 1 and b is equal to 0 and c is equal to 0 and d is also equal to 1. These 4 values we have to substitute in equation number 1. Here what we have to get, the a value is 1, b value is 0, c value is 0 and d also 1. Now we have to substitute in the equation. We get x cube plus x plus 1 divided by x square plus 1 whole square is equal ax plus b. What is the a value? 1. 1x plus b, 1x plus 0. So that x divided by x square plus 1. Next, plus cx plus d. What is the c value? 0. D value is what? Cx means c into 0. 0 into anything will be 0. So that 0 plus 1 divided by x square plus 1 whole square. Okay. So that here to observe, any irreducible quadratic factor is repeated, then the partial fraction format is ax plus b divided by something x square plus 1 and cx plus d divided by x square plus 1 whole square. Suppose the quadratic factor, irreducible quadratic factor is repeated again 3 times is there, then how to write in partial fraction format? Ax plus b divided by x square plus 1 one time, bx cx plus d divided by x square plus 1 whole square plus ex plus f divided by x square plus 1 whole cube. So that how many times? 3 times repeated. Then write a, b, c, d, e values we have to find out. Okay? Yes. Number 3, resolve 3x square plus 1 divided by x square plus 1 to the power of 4 into partial fraction. Okay, resolve 3x square plus 1 divided by x square plus 1 to the power of 4 into partial fraction. Here, before going to the partial fraction format, it is easy way to solve them. That is, the method is put x square plus 1 equal to y in the place of x square plus 1 equal to y. That is, x square is equal y minus 1. 3x square plus 1 divided by x square plus 1 to the power of 4 is equal, in the place of x is what? Y minus 1. So the 3 into y minus 1 whole square plus 1 by x square plus 1 is equal to what? Y. So that y to the power of 4. So that 3x square, 3 into y minus 1 whole square, 3y square minus 2 divided by y to the power of 4. Now we have to split in two parts. 3 divided by y cube minus 2 divided by y to the power of 4. And again, in the place of y, we substitute x square plus 1 whole cube minus 2 divided by x square plus 1 to the power of 4. Okay, so that in the third question is to the different types of problem by using the substitution method. Put x square plus 1 equal to y, that is x square equal y minus 1. In the place of x, we have to substitute x square y minus 1 is there. Okay, now here 3 into y minus 1 plus 1y y to the power of 4. 3y minus 3 plus 1 equal minus 2. So that 3y minus 2 divided by y to the power of 4. Now we have to split into two parts. 3y by y power 4 minus 2 divided by y power 4. Here y cancel and 2 divided by y power 4. Now here what is the value of y again? X square plus 1. So that in the place of y, x square plus 1 we have to substitute. So that we get 3 divided by x square plus 1 whole cube minus 2 divided by x square plus 1 4 to the power of 4. So that in this method, we observe here irreducible repeated quadratic factor is there. So that one repeated linear factor is there, another one is non-repeated linear factor is there, one non-repeated irreducible factor and repeated irreducible factor. The totally 4 methods are there, 4 types of partial fractions are available. Okay, then we have to resolve it into a partial fraction. The different method we have to apply whenever the repeated non-repeated is there, then how to write in partial fraction format, and repeated irreducible and non-repeated irreducible quadratic factor is there, then how to write the partial fraction format we have to learn about here. Now we go to the summary. In this session we have learned about resolving the rational fraction into partial fractions when the denominator has repeated irreducible quadratic factors. Are we clear here? Whenever given the repeated irreducible quadratic factor is there, then how to write in partial fraction format? Ax plus b divided by something, cx plus d divided by something, and also continuous ax plus b or cx plus d or ex plus f to be continuous procedure. Okay, now we see the quiz. Number 1, if x power 4 plus 24x square plus 28 divided by x square plus 1 to the power of 3. Okay, here this is a proper fraction. You observe the degree, the numerator degree is less than denominator degree. Here you observe the denominator part. Irreducible quadratic factor is repeated. How many times repeated? 3 times is repeated. Okay, that is equal ax plus b divided by x square plus 1 plus cx plus d divided by x square plus 1 whole square plus ex plus f divided by x square plus 1 whole cube. Then a is equal what? Then a is equal to what? Okay, then this is a lengthy method, lengthy procedure. By find out the a value, we have to first of all we find first we find out the LCM part. Then after that simplification using the comparing the coefficients of x cube, x power 4 or x square or x or constant or variable of x anything. Then after that we have to choose, we choose the equations 3, 4, 5 anything. By using that equation we have to find the value of a, and also b, c, d, e, f is available. Okay, in this one option is given a is equal to 0 and also b is equal to 1 and c is equal to -1, d is none of the above. Okay, now we see the second question. If x square plus 10 divided by x square plus 1 power 2. You observe here also the denominator is 2 times repeated. Okay, the denominator is which type? Linear factor or quadratic factor? This is the repeated irreducible quadratic factors. Okay, if x square plus 10 divided by x square plus 1 whole square is equal k divided by x square plus 1 plus 9 divided by x square plus 1 whole square, then k is equal to what? Okay, the same type here, x square plus 1 whole square in the place of k, so that here ax plus b we have to choose. First of all we write the partial fraction format, then write in the place of k is what is the suitable value is there, then we have to find out. The same procedure we apply, find out the LCM and simplify the equation and find out the a value and b value and also c value and also d value here. Then after that ax plus b value, which value is there, then the suitable answer you have to find out. In this one the options are available. A is equal to 1 and b is equal to 2 and also c equal to 3 and d equal to 4. What is the suitable answer? We have to find out. Sorry. Now the last one is assignment. You see this assignment, the first question is resolve 1 by x minus 2 into x square plus 3 whole square into partial fraction. You observe here the numerator is only the one value is there, denominator is x cube is there. This is confirm the proper fraction. Here x minus 2 is linear factor, non-repeated linear factor. X square plus 3 whole square is a repeated irreducible quadratic factor. One linear factor is there, one is repeated irreducible quadratic factor is there. So that how to write the partial fraction format here? We write a by x minus 2 plus bx plus c by x square plus 3. A, b, c is over. Now we go to the d. Dx plus e divided by x square plus 3 whole square. Here how many values are there? A, B, C, D, E. So that here we find out the A value, B value, C value, D value, E value. How to find out this one? You have to using the LCM procedure and cancel the denominator values and simplify the equations. We have to choose the main equation number 1. Then after that, using the substitution method is possible. Then you have to apply. And otherwise, we have to using the comparing the coefficients. How to compare the coefficients? The first one is comparing the coefficient of the highest powers. Here what is the highest power is possible? X power 4 is possible. So that comparing the coefficient of x power 4, comparing the coefficient of x cube, comparing the coefficient of x square, comparing the coefficient of x, and comparing the constants. Here each and every part we have to choosing the different equation here, different equations. Then after that, using these different equation, we have to find the values of A, B, C, D, E, F. Sorry, A, B, C, D, E. Those are enough. A value and B value, C value and D value, E value and F value. These 5 values we have to substitute in the main equation. We get the resolving into a partial fractions. Okay. Now we see the second question. Resolve x cube plus x plus 1 resolve x cube plus x plus 1 divided by x square minus 1 whole square, x square plus 2 whole square into partial fractions. Now here also you observe the numerator degree and denominator degree compare. This is also proper fraction. Now here you observe the denominator x square minus 1 whole square and x square plus 2 whole square. Here two repeated quadratic factors are there, but those are to be repeated again. Then how to write in partial fraction format? That is here x square minus 1 whole square is there. So that ax plus b divided by x square minus 1 plus cx plus d divided by x square minus 1 whole square plus ex plus f divided by x square plus 2. Next, fx plus g divided by x square plus 2 whole square. So that whenever comparing this one, this is the lengthy procedure problem. Here we have to find the values a, b, c, d, e, f, g, h. A, b, c, d, E, F, G, H. Here how many values we have to find out? A value, B value, C value, D value, E value, F value, G value we have to find out here. So that how to find out here? The same procedure we have to follow. Take the LCM part and cancel the denominator values and simplify the equations, and also using the same comparing the coefficients. It is very lengthy procedure comparing the coefficients. Comparing the coefficient of x cube x power 4, comparing the coefficient of x square, comparing the coefficient of x constant terms. Then after that we have to choosing the different equation. Then after that simplification we have to find out the a value, b value, c value, D value, E value, F value and also G value and also h value. So that here a value, b value, c value, d value, e value, f value, g value, h value. So totally how many values? 8 values are there. The value we have to substitute in the main equation. We get the resolving into a partial fractions. So that whenever we compare, this problem is very lengthy. Okay, but the totally depends on the factors. Suppose linear factor is repeated, then we have to write the a by something and b by something. Quadratic factor is repeated, then write ax plus b by something and cx plus d by something. That is only the main procedure. Okay, so that the before classes and this classes also will learn about how to resolving into a partial fraction using the different methods. Okay, and also we know about the different types of fraction. How can we define a proper fraction, how can we define a improper fraction, and how to resolve it into a partial fractions. Whenever given the improper fraction is there, how to write the resolving into a partial fraction, we have to convert it in the proper fraction, then after the resolving into a partial fractions. So that resolving into a partial fractions, the totally 4 methods are there. In this the 4 methods, one is non-repeated linear factor, repeated linear factor, and non-repeated irreducible quadratic factor, and repeated irreducible quadratic factors. Okay, are you understanding clearly? So the next class we go to the next topic. Okay, thank you very much.